Sensing the world. Sensory receptors. Sensory receptors are special parts of our body that help us sense and respond to the world around us. They are like tiny detectors that detect different things and send messages to our brain, which helps us understand what we are experiencing. Sensory receptors are found in various parts of our body, such as our eyes, ears, nose, tongue, skin, and other organs. Olfactory receptors. Hair cells. Mechanoreceptors. Taste buds. Photoreceptors. Olfactory receptors. Olfactory receptors are a type of sensory receptors located in the nose. They are responsible for our sense of smell. These receptors are specialized cells that detect different odor molecules present in the air. When we inhale or smell something, these molecules come into contact with the olfactory receptors in our nasal passages. The olfactory receptors then send signals to the brain, which processes the information and allows us to perceive and identify different smells. This diagram demonstrates how the input of odor molecules interacts with the process of olfactory receptors and leads to the response of perceiving smells through brain perception. Sensory input. Odor molecules in the air are the input to our sense of smell. Process. The olfactory receptors in our nose detect these odor molecules. Response. The olfactory receptors then send signals or messages to our brain. Hair cells. Hair cells are the sensory receptors responsible for our sense of hearing. They are specialized cells found in the inner ear, specifically in the cochlea. Hair cells play a vital role in converting sound vibrations into electrical signals that can be interpreted by the brain. Hair cells are delicate and can be easily damaged. Excessive noise exposure, certain medications, or aging can lead to hair cell damage, resulting in hearing loss or impairment. This diagram represents how the input of sound waves interacts with the process of hair cells, which then leads to the response of electrical signals and ultimately brain perception of various sounds. Sensory input. Sound waves are the input to our sense of hearing. Process. Hair cells detect the sound waves and convert them into electrical signals. Response. The electrical signals are transmitted through the auditory nerve. Mechanoreceptors. Mechanoreceptors are sensory receptors that are specialized in detecting mechanical stimuli, such as pressure, touch, vibration, and stretch. They are found throughout the body, including the skin, muscles, joints, and internal organs. Mechanoreceptors play a crucial role in our ability to sense and perceive tactile sensations. This diagram represents how the input of mechanical stimuli interacts with the process of mechanoreceptors, leading to the brain's perception of various tactile sensations. Sensory input. Mechanical stimuli act as the input to our sense of touch or tactile sensations. Process. Mechanoreceptors detect and respond to mechanical stimuli. Response. The electrical signals are transmitted through sensory nerves to the brain. Photoreceptors. Photoreceptors are specialized cells found in the retina of the eye that are responsible for detecting and responding to light. Rods. Rods are more numerous than cones and are primarily responsible for vision in low light conditions, such as at night or in dimly lit environments. Cones. Cones are responsible for color vision and visual acuity in bright light conditions. They are less sensitive to light than rods, but provide higher resolution and the ability to discern different colors. This diagram represents how the input of light waves interacts with the process of photoreceptors, leading to the response of nerve signals and ultimately brain perception of vision. Sensory input. Light waves act as the input for our sense of vision. Process. Photoreceptors detect and respond to light. Response. The nerve signals generated through the optic nerve to the brain. Taste buds. Taste buds are sensory organs located on the surface of the tongue and some other areas of the oral cavity. They are responsible for a sense of taste, allowing us to perceive and distinguish different flavors. The taste receptor cells are the key players in taste perception. They have microscopic hair-like projections called taste hairs or microvilli that extend into a small opening, called a taste pore. This diagram represents how the input of taste molecules interacts with the process of taste buds, leading to the response of nerve signals, and ultimately brain perception of various tastes. Sensory input. Taste molecules from the food we consume act as the input for our sense of taste. Process. Taste buds detect and respond to the taste molecules. Response. The nerve signals are transmitted through the taste nerves to the brain.